So we have security researchers that go to the dark web, download the tools, reverse engineer them, and then trying to simulate the different attack patterns. So you have examples, or you know what you're trying to combat, right? And once you have this starting point, you're evolving more and more the models and the sophistication.
Welcome to the DevSec for Scale podcast, the show that makes security a first-class citizen for growing companies. Welcome back to the DevSec for Scale podcast. I'm Jeremy Hess, and with me today is an awesome guest, Lidan Hazout. He's the Risk and Fraud Detection Director at a cool company called Transmit Security, which we'll get into in just a little bit. Lidan, thanks for coming on the show.
Thanks for having me.
Yeah, absolutely. So the first thing I want to get into right away before we talk about you and what you're up to is we've been hearing a lot over many years. We're going to be talking about machine learning in this episode. So, strap in, get your buckle on, get ready to go. So machine learning is obviously something we've been hearing about for many years, and people really associate it all the time with AI. And, is it really the same thing? Is it something similar? What is that connection? And, explain to us a little bit what machine learning is and why it's important in the security space.
Yeah, great. That's a great question. So first of all, people in many cases confuse or reuse the terms between machine learning and AI. So they're similar terms, but machine learning focus about our ability to train the machine or computers to learn statistical patterns and to reapply them on new problems, right? Comparing to AI, which is trying to make the machine behaves as a human being. And we've seen it a lot with the LLMs models that are now very common. So there are a lot of shared space and same technologies, but the terms are a bit different. So for security purposes, we use machine learning to multiple use cases. One of the things that I focus on is for detection capabilities, meaning that we were able to detect new attack as they emerge based on our knowledge from previous attacks. So we're automating that process and learning the machine how to detect those attacks very effectively, meaning that being very accurate in our detection, not missing some of the attack, or not don't have false positive and mislabels legitimate access, which are not really attacks.
Got it. Yeah, there's a lot of different issues to dig into from an IAM level and hacking and other cyber issues. So now that we know a little bit more about machine learning and why it's important, let's get a little bit into Lidan. So tell us a little bit about yourself, what you've been up to until now, what you're doing at Transmit, and what Transmit Security does.
So for the past 10 years, I'm focusing in the engineering world. R&D really loves, developing cool products and software. I really like the backend side, working with the data, and working on the infrastructure to being able to serve complex logics, machine learning in real time. So those are the challenges that I focus on. And we have these challenges in the security world, right? Because you work in real-time space, a complex problem, and people trying to bypass your system. So it's always interesting. It's always exciting. So previously I worked in a company which called SecureTouch. I was the VP R&D there, and then the company was acquired. So that was a great experience. And now I started, or in the past year and a half, I started to work at Transmit Security. And we created a new product, which is called Detection and Response, which is in this world of security, detection, working with machine learning, data science, which is very cool. And we have a great team of experts. And every day we're tackling new problems, which is exciting.
All right, fantastic. So getting back to our topic of machine learning, what are some of the various types of machine learning, and what is your preferred method when you're talking about your own product?
Yeah, so that's a great question. So in the world of machine learning or data science, we categorize the type of models into multiple categories. So one of the most popular one will be the supervised model, where we introduced known examples and train the model to be able to detect similar cases. We also have the unsupervised approach, where we don't have known examples, but the model learns the patterns of the population and distribution, and then being able to detect anomalies, outlier, from that area. And we also have what we call reinforcement learning, which is a type of learning that you introduce to the model adaptive learning throughout time. So it's more for a time series approach and be able to have a target optimization function. So for our area, we realized that being able to do the semi-supervised approach, it was yielding the best result, as we are getting some known examples, but we know that new attacks will have different characteristics. So the model takes that into account, and being able to both detect known attacks and being able to detect anomalies and new patterns of attacks. So that was the most effective method for us.
Got it. Yeah, and then we also talked about the idea of figuring out what attacks or are not really attacks, right? Sometimes false positives and things like that. So in that sort of situations, how do you actually train machine learning? Let's say we'll go with the supervised learning approach. How do you train them to recognize the attacks, and how do you know it's actually doing its job correctly?
Yeah. So first of all, it's all about the data, right? You need to collect enough data to have significant distribution, understanding of the feature. So you need to clean the data, run the feature engineering, and really understand how you collect it, how you process it, and how you establish a clean data set. Once you have it, you need to have your goal, your KPI, your benchmark that you would like to optimize. So usually you start with a benchmark, a very basic configuration of a model, and then you will try to improve over and over again. So you have to trust your results. There is a method which is called cross-validation, which you retrain the model multiple times to have a KPI that you can trust. And from there, you can try to optimize the type of the model, the hyperparameters, the data that you collect. So it's a continuous process that our data science team is doing. And when you need to have the infrastructure in place to be able to process large amount of data points. And obviously, after you have the model, you need to somehow serve the result, do the inference part. So that's also engineering challenge from that perspective.
Yeah, that brings us actually into our next question, which is talking about the what are the sort of like the infrastructure that you would need, and what sort of skills do the engineers need in order to train and run these models, especially when we're talking about a large scale?
Yeah, so that's an interesting question, because in the past we had backend engineers that work with the data science, and they collaborate together. In many cases, the researcher was doing only the research part, and then the backend will try to boost that. We evolved since then, and now we have multiple roles that specialize in this area. So there are data engineers and there are machine learning engineers that really are experts in understanding how the model behaves, what the requirements, how we can run it, how we can optimize it. So there is a lot to it. There are a lot of frameworks, open source project, and a lot of knowledge, because that's a specialized set of problems. So it's not straightforward, and you want to do it in things like low latency and verify that from a quality perspective, you're not causing issues or degrading the model efficacy. So I think we really evolved in the past few years, and the team really doing amazing jobs and taking those complex problems, breaking them down, and use specialized tools to solve each and every problem.
Really awesome. I mean, are there really well-known tools already in the industry that are being used, specific things, or are you also building your own, let's say, open source products or open source tools to be able to, or even not open source tools, to be able to sort of deal with more advanced type of attacks?
So I think there are some known projects that the community of data science and machine learning engineering really work on with the daily basis. So there is the sklearn project, or the PyTorch approach for networks and deep learning, and there also is more modern frameworks for the machine learning engineering and for the data engineering, which called Kubeflow, which work running the data on Kubernetes infrastructure. So there are some really popular open source projects that you can use, but you will still need to build on top of that, customize, really understand what's the set of tools that you will need to pick up. Really, like every other engineering project where you have a lot of options, and you need to choose the best setup for your type of problem.
Yeah, awesome. So I want to talk a little about sort of your methods for the way that you build a security product from this risk, analysis side and from this machine learning side. What sort of methodology do you use when you're thinking about building a security product from the side of the cyber risks and machine learning?
Yeah. So when you start working on such product, it's hard because you don't have any cases of real attacks, right? You're in the lab, so you need to somehow simulate those cases, right? So we have security researchers that go to the dark web, download the tools, reverse engineer them, and then trying to simulate the different attack patterns. So you have examples, or you know what you're trying to combat, right? And once you have this starting point, you're evolving more and more the models and the sophistication. So we start working with design partners. We got real data sets, so we can do the analysis. And once we understand the data points, the feature, the distribution, the examples of attack, then we can really create a robust model that will be optimized to real world scenarios. And from the quality perspective, it's very critical, right? Because if you have false positive or deny falsely good users, then that's a real issue and business impact. Or the other way around, let's say that you're missing important attacks, then that will also impact the business negatively. So from quality perspective and being able to assure that your model produce good results, there are a lot of research and efforts going into that. So I think that it's a very interesting challenge, and I think that in the past 2 years that we're working on this product, we were able to achieve a lot of interesting and cool examples of models that run in production and really provide real value to our customers.
Yeah, really cool. And is there any sort of example that you can give us about how you're training the actual, machine learning based on this type of methodology?
Yeah, so I can share an example of a specific type of model that we have. So we have a bot model that can detect bot attacks in real time. So again, we started with creating our own bots, right? And you have basic type of bots. You can write a script that automates some, in a web browser, clicks on some buttons and try to do some stuff. And at first it's very basic, right? Because it's very synthetic. But then we realized there are more and more sophisticated bots. Even sometimes they call it human bots, where actually the bot mimics the mouse movement, and it can mimic how the real user types in at the keyboard. So then it gets in more and more nuances. So for example, we can calculate how fast you click on every character in the keyboard, and if you did a typing mistake, or your variance between or speed between different typing. So you're getting into those micro nuances in order to being able to really differentiate between human beings and bots that always evolve and trying to look more and more human. So it's a really interesting problem, and that's actually a cool example of how we use machine learning to solve this issue.
Yeah, that's a really interesting one because there must be such a variance between the way a human, one human and another human click and type and move around the screen. So it must be sort of like a percentage type of thing. Like you can't necessarily be 100% sure that this bot, which is acting so similar to a human, is really a bot. There has to be some sort of percentage out there that says, okay, well, statistically, we could say that 70% chance this is a bot and not a human, or 80% we could tell this is a human and not a bot. Is there some measurement like that, or do you get to almost 100% accuracy with this?
So exactly, yeah. So the model, it's a prediction model, or a classification model which produce a probability score. So it takes all the different features, all the different statistical analysis that he's doing, and in trying to produce this probability. So there are times that the model is not sure. To both way around, it might be human being, it might be a bot. And then you need at the product level to take that into account, right? You need to have this middle ground and guide your customer what they should do in that middle ground. So for example, for bots, you can try to challenge them. We don't really like all those captcha things that you need to move things around to to prove that you're human, because that's provide bad user experience. But we do have other challenges that you can use. For example, verify your identification through other channels like email or OTP, etc. But the problem is still remains that there are some cases where you're not sure, the model is not sure, and then you at the product level you need to somehow handle that. And we always strive that to make this area of middle ground as small as possible. So in most cases, the model will get an accurate result.
Yeah, and the rare cases, I assume, where you're not sure or the model isn't sure, then probably you want to sort of classify it as a bad actor rather than someone that's okay, that's good to go. That way, at least if something goes wrong and you have a customer who says, it's telling me that I can't log in because it thinks I'm, something else, then at least you have a way to remediate that, where the user can say like, this isn't working for me. And then there must be a way for them to then request some access after that or have another sort of verification. Is it like a multi-step verification if it's just not sure?
Yeah, so we usually have like 3 areas, right? If the model is completely sure, then we'll deny the request and do the full protection. If we completely think it's a human, then we'll let him pass freely and no interference with the behavior. But for the middle ground, you call it like the challenge. We will challenge the user to prove he is a real human being. So that will require him to re-authenticate using other channels and methods that the bot wouldn't have access to. So we use this method to protect your account, basically. So it will cause you some friction, but the goal is to prevent from an attacker taking over your account. And we try to minimize those cases. But yeah, there will be still cases that will need to handle that at the product level.
Got it. Yeah. So one of the topics that's really interesting to me, in terms of the difference in the variability of attacks that happen, what's like some of the most basic, obvious type of attack that you see that's like, okay, well, we got this, we know 100%. And then what's more like a really sort of sophisticated attack that you've seen lately that's kind of really making it difficult to train your models to learn?
Yeah, so that's actually an interesting question. So, when we see type of attack, like when you try to spoof the device or use an emulator or a virtual machine, then those are much more deterministic cases, and that will be easier for the models to pick up and say, okay, that's fraudulent. But when there are more complicated things like social engineering and fraudsters or attackers that will guide you to conduct the security breach, then that's much harder, because the normal user might use their same device and might be a real human being and might have all those characteristics of real user, but actually the attacker is tricking them into doing something they didn't mean to, or that will damage their business. So those are the more complex attacks, and attackers knows that. So they're really making more and more sophisticated types of patterns. And I think we've seen those articles about companies that are being targeted by social engineering attacks and the losses and damages. And I think that will keep going and keep evolving as the way of the technologies are enabling those attackers to social engineer them, or even use AI to try to convince the targeted users that they are real organization that trying to guide them to harm or to breach their actual accounts.
Yeah, I feel like social engineering must be almost impossible, in my mind at least, to train a machine to recognize let's say a behavioral pattern, not a clicking pattern, not the way you're typing, the way you're moving on the screen, but a behavioral pattern that's sort of outside of a computer. I mean, you could be on a phone with somebody who's trying to tell you to go do something. It's really hard to figure out how you could potentially stop somebody who's being convinced that they should log into their account or they should do X, Y, and Z, and then maybe even give their credentials to somebody. So how does that factor into training a model for this kind of attack?
So actually, there are small nuances in the behavior of a human being where they're under stress or they are being guided. So think about, you might switch on and off from the actual application or the actual access to your text messaging, or you're on the phone when someone guides you. So those nuances of stress signals, delays in activities, or being guided can be picked by models. Obviously, you have more margin of error there, but there are ways to mitigate. It's a lot about educating the user. It's a lot about being able to detect those cases and let the user know that something might be wrong. They shouldn't be guided. Should never share their credentials with anyone else, or move money or transaction to unknown accounts. So I think we're more and more involving in this space because we're seeing more and more of those attacks. But as fraudsters using advanced technology to conduct those cases, we as well. So we will use the models to detect these cases, and things like AI to help you really understand that you're under attack and help the user prevent this from happening in the first place.
Yeah, that's really an interesting way to phrase it, to jump from sort of like a machine learning to actually having an AI on top of it, and to actually give sort of that even more security and direction for the users to help them recognize when something's going wrong, hopefully in real time. Yeah, so this has been fantastic, Lidan. I have one more question that I like to ask all of my guests, and that is, what are one or two tips that developers can use today that can help them be more secure without imposing too much on their development time?
Yeah, so I think that in this space, there is a lot. There is so much information and so much knowledge that you can get, and it's very hard to know where to start from. So I think that I would recommend someone to pick a subject or pick an area that they interested in, like a problem that they find interesting, and investigate that specific area and learn models that can help them solve this solution. Really trying to play with them. You can try in the abstract level as an engineer, and then as you go along, get more and more expertise in how the model works, how to optimize it, how to tune it. And there are a lot of courses and material that you can start reading. There's a very cool site which is called Kaggle, which you can really compete in a machine learning and data science problems, and then you can learn as you go along the best way to solve the specific issue. What's the best way to tackle that? So I think that's a very cool way to get into machine learning, data science world. And I know it's intimidating. I know it seems like a lot of math or statistics, but actually the modern technology really helps you get into that fairly quickly. And as you move along, you can get more and more expertise in that area. And also for our engineering or people that are interested in the engineering side, I do think there are some very cool project or services that you can work with, big scale of data, deploy the models to the cloud. I mentioned Kubeflow earlier, which is a very cool project that I recommend people to get into and really understand the ecosystem of using distributed computation and machine learning together. And yeah, I think that we're at a place which it's an amazing opportunity, because we've seen more and more models, buzz, use cases that are now solvable using AI and machine learning. So I think more and more people will join this technology or this topic. So it's really exciting, and yeah, I'm happy to be part of that.
Fantastic, Lidan. Thank you so much for your time. This was a great episode. I think we got into a lot of the sort of general sides of what machine learning is, what it does, and then we got into some cool topics about sort of what attacks we're seeing and what's happening now in the field. So really, really cool stuff. All the best of luck with continuing to build this out in your product and all that, and best of luck going forward. So thanks so much, and to the audience, as always, stay secure.